In this video here, we're going to be looking at Chapter 1 test, the review. So we're going to start reviewing for the test. I'm going to do half of the problems from the review in this video and then the other half in another video. So let's get started. So with level 1 problems, again, these are evaluating functions. So you might be given an equation and asked to plug in something and then work it out to simplify. So let's start with number 1 here. If I were to work out this says I need to plug in -4 in for x, so I'll go ahead and do that. So this would give me 5, -4 squared minus 9. So I would do order of operation first, so exponents in this case needs to come first. So that's going to be 16 minus 9. Now 5 times 16 gives me 80. And this is the part where you can grab out a calculator to help you out. And 80 minus 9 is 71. So 71 is my final answer. I'm going to be plugging in a 7 for part 2. So number 2, I need to plug in 7 for the x this time. So that would give me 49. If I'm square the 7, 5 times 49 is 245. Subtract 9 is going to give me 236. So these are very big numbers, and that's because we have a power here. And then this one is interesting because it has an 8x. So I'm going to be plugging 8x instead of the x here. So that's going to look like 8x squared minus 9. So not only do you have to square the 8, but you need to square the x inside. So that's going to look like 64x squared minus 9. And then you're going to multiply this 5 with the coefficient in front. So 64 times 5 gives me 320. X squared gets just brought down, and then the minus 9 is brought down as well, but I can't combine these two because they are not like terms, so this is my final answer. All right, and then this one here has an x minus 2 that you're plugging in, so remember you want to keep things in parentheses. So this is going to be 5 square x minus 2 squared minus 9. Sorry, I meant to say 5 times x minus 2 squared minus 9. So remember, when you have a square that has a factor, you need to FOIL it out. So I'm going to do that to the side here. So that's going to look like x minus 2 times x minus 2. So if you FOIL this out, you get x squared minus 2, x minus 2x plus 4. So these two middle terms will combine to give you -4x plus 4. And so I would bring that down next to the 5. And now I would go ahead and distribute the 5 in. So this would be 5x squared minus 20x plus 20 minus 9. So at least these two terms I can actually combine. So 20 minus 9 gives me 11, positive 11. And then the rest looks good. I can't combine any further. So this here is my final answer. And then for our graphs here in the next part, it's asking that using these two graphs that you're given, you can also evaluate the function. So this one, you don't have to deal with equation. Just looking at the x value that they give you, you can find the output or the y value. So this first one here has a -3 for x. So this is associated to the f equation. So I have to look at this graph. -3 is right here. You can see that the y value on this curve would be here, which is at +1. So this answer would be +1. This one is at 0 for g, so I would go to g, go to x equals 0, and I noticed that my y value is a 4 there. And then this one here, these two are inverses. So when they are inverses, let's just remind ourselves, anytime you have an inverse, the inside is actually a y, and what it's giving out is an x. So this 3 here is going to be a y value. So you would have to go to f, because this says the inverse of f, and we have to go to the y value of 3, which is here. And on the graph, the only place that it touches 3 is this point here, which is the x value to 6. So at y equals 3, the x value is 6. Whereas this one here is the inverse of g, so I have to go to this one. The y value 6, so here, so the x value needs to be, so if this is y equals 6, that's where it's going to hit, and the x value is negative 3. And there we go. So pretty easy when you're given a graph as well. And for piecewise functions, if you remember from earlier videos, this piecewise function has 2 functions, so you have to determine which function to use. So this one, you have a -2 for x. So when you look at the piecewise function, you need to look at the interval section and test which one you would use. So if this is -2, -2 is less than 5, so you would use the first equation. So I'm going to go ahead and plug it into the first equation. So I'm going to put a little note here that I'm using the first equation, and I'll plug in -2 and work this out. So this gives me +6 plus 1, which gives me 7. So in this case, my answer is 7. As for this one, I'm plugging in 6. So if I plug in 6, I have to go to the second equation because 6 is bigger than 5. So for the second equation here, I'm going to be plugging in 6. So that's -6 squared plus 11. And so if I work this out, I have to square this number first before I can take this negative. So 6 squared is 36. Then bring down the negative. If I add -36 to 11, I get -25. Yes, so that looks right. And so this would be my final answer. And then this next one here, I have 5. Now, both of these have a 5 in it, but the one that says equal 5 is the second equation. So I have to plug this into the second equation. So plugging the 5 in for the x squared and working this out, you'll get -25 plus 11, which gives me -14 as my final answer. All right, let's get into level 2 problems. So level 2, we're going to be looking at translation. So how do you move things on a graph? Do you understand the shifts? And can you find the domain and range? As well as level 2 problems are looking at max and mins and increasing and decreasing intervals. So first, let's look at these equations, and it's asking if you can figure out the change from its parent function. So do you know, or can you describe the shifts? And then stating the domain and range for that equation. So first off, when I'm looking at a problem like this with a x cubed, I know immediately this is a cube function. So I'm going to label this as a cube. And when I'm looking at cube functions, let's understand the graph for a moment for cubes. Cube function looks like a lightning bulb to me. For a typical cube function, that's positive. But if you have a negative, you might remember this. Or if you don't remember, just graph it into Desmos to see what the picture looks like. But if you have a cube function that has a negative in front, like what we have, it flips the graph. And so basically it flipped across the x-axis. So I'm going to state this reflects over the x-axis. Okay, so in this case, I knew that because there was a negative sign here. So if you go back to a previous journal, I think journal 3, or you go back to the quiz review, you'll see all the different types of shifts. So in this case, you have a shift that reflects over the x-axis. Now for the domain, this cubic function, as you can see, at least the blue one here, points in the left direction and the right direction. So it is going to be approaching negative infinity and positive infinity if it's pointing left and right. And it's pointing, so in this case, domain is all real numbers. And it's pointing down and up. So it's going to negative infinity and positive infinity in the y direction. So it's also all real numbers. In fact, for a cubic function, the domain and range is always all real numbers. So it's a nice one to remember. Now for this one here, we have a square root. So if we have a square root, the graph you might remember typically looks like a shooting star, but I'll just draw it out for you guys. That way you guys might remember. But it starts at the origin and then it goes outwards to the right. So it starts from 0 and goes to infinity. Now, if we have this type of curve, then you're going to have a left shift because it's a positive 4. So we're going to be shifting left 4. And this here, this 2 here is a coefficient in front of the x or in front of the root. So that tells me that this is going to be multiplied. So the numbers are going to get bigger, which causes the equation to be more narrow or steeper because the numbers are growing faster. So in that case, if we were to draw this, this would shift again to left 4. And this here, you can treat this as the slope. So that slope is 2 over 1. So you would go up 2 over 1. Just one time. Just only use it one time. And then draw your curve. So in this case, this is going also to the right. So it's going from negative 4 to infinity. So the domain's negative 4 to infinity, and I need a bracket at the negative 4 because it does touch it at negative 4. As for the range, notice that the range is still the same as the original graph. It starts at y equals 0, this baseline here, the x-axis, and it is shooting upwards, so it's going to positive infinity, so 0 to infinity, and also you want a bracket on the 0 because it is touching it at y equals 0, and that's it. This one here is a quadratic because you can see the 2 here, the power of 2. So this is going to, I'm just going to write quadratic here so I can remember. Now quadratic makes a parabola. So I think we've drawn a bunch of parabolas at this point. So that U shape. But in this case, this parabola is minus 3 plus 1. So that means this is right 3 up 1, so that inside has a negative 3, so that's why I know it goes right, and this positive 1 means up 1. So if I go right 3 and up 1, I would be right here. Now there's no minus sign here, so I know that this parabola is still pointing upwards. And so that would be my parabola for this equation. And so when I look at this, the domain is still stretching left and right. So the domain is still all real numbers. And we've said this multiple times before, that when we have a quadratic, the domain is always all real numbers. Whereas the range is a little bit more restricted. The range here starts at this minimum, which is at 1 for the y value. And then it keeps increasing. So it's going from positive 1 to infinity because we have that vertical shift. And that's it. So I filled in the translation in other words, I have described the translation and I've also figured out the domain and range. For number 16, you're going to be using this graph to answer these following questions. So let's start with the domain. So domain's talking about how far it stretches left and right for its x values. So when I'm looking at this graph here, I notice that the x stretches all the way to -5. This is the furthest x value to the negative side. So the furthest left value here is -5. And it keeps going, 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 and then it kind of breaks a little bit. So first off, it keeps going in this direction, and there's an asymptote here. So that means it's going to get really darn close to the asymptote, but not quite touch it. So that tells me that it's approaching this number here. That x value is a 2. So because we're getting really close to this 2, but not quite touching it because it's an asymptote, we have to use a parentheses. So asymptotes, if it's approaching an asymptote, you want to use a parentheses to tell that you are not touching it. Whereas this -5 here, notice it's a solid dot, so I can actually use a bracket here on the 5. Now it keeps extending, so it's going from 2 and onwards to infinity. So it goes to 2 to infinity, so that tells me it continues 2 and onwards. And so I want to represent this curve 2 and its domain. Whereas the range, it's a little bit trickier because you'll notice there's not much of a break when it comes to the range. This side, the lowest that it points downwards, it has an arrow. So this is pointing downwards with an arrow to -infinity. But notice that when you start to look upwards, this here is a continuous curve that points upwards to positive infinity. In fact, there is no break here, so it's going from negative infinity to positive infinity. So in this case, you have all real numbers, or you can write negative infinity to positive infinity, whichever one works for you guys. Now for the increasing intervals, you'll notice the increasing is when, if you think of this as a roller coaster, it's when it's going up. So this part here, let me see if I can grab a pen, would be increasing. And then I don't think I see any other parts of the curve that's increasing, because this looks like decreasing, decreasing, decreasing. So I only have one increasing piece, and it's right here. And it goes from, when you do intervals, you want to write x values. It goes from here, which is where it starts, which is at -2, to here, which is at the peak, and that's 0. So from -2 to 0, it is increasing. Whereas if I were to do decreasing, this here would be decreasing. So with this piece, which has an arrow, and then this piece here is also considered decreasing. So if I looked at the first one, this is going from -5 to -2. So this is going from -5 to -2 on the x-axis, where it's showing me that it's decreasing. So that's my first interval. But it's the second interval that looks really interesting. So notice how this one is falling downwards from 0 to 2. When x is 0 to 2, it is decreasing. Let me put a little mark here. But also it's decreasing, it continues to decrease from 2 to infinity. So in this case, all of this section here is decreasing. So I can really say from 0 to infinity, it's decreasing. So there's really no break for it to here. So it goes from 0 to infinity, it's decreasing. And that's just because when it starts at 0, it's decreasing from 0 to 2, but then it's again decreasing from 2 to infinity. So I can just say all of this part here, this part of the axis, x-axis, is decreasing. So that's why I can represent it as one interval rather than two more. All right, let's talk about relative max. So max is talking about when you have a curve, the top peak of the curve or the hill of the curve. So I notice I have, this one would be considered a max. This one is also considered a relative max or local max because with this looks kind of what the maximum part of this section. This local section looks like this would have been the highest point. So we can also consider that as a max. So there are two max here. I think that's it. So I'm going to write the coordinates down. So for the first one, this looks like at negative 5, 3. And the second one is right here at 0, 3. Whereas the relative min here would be down here, because that is the dip of, so if you're looking at mins, you're going to need to look at the dip. And so we do have a dip here at negative 2, negative 2. And I think that's it for a minimum. I wouldn't consider this a minimum, even though it looks kind of like a dip, because it's still decreasing further down. So if you notice that it still technically continues to decrease, then you can't count that as a minimum or like a relative minimum. Now let's talk about absolutes. So absolute means like what is the highest y value it's approaching and what is the lowest y value it's approaching. So absolute max is talking about the highest y value that it's approaching on the graph. Now, if you remember when I was talking about the range, notice that the highest y value it's pointing towards is infinity because it does have an arrow. So the absolute max here is infinity. Whereas the absolute min here is the lowest that it will drop for the y values, and that in this case is pointing down with an arrow on this part of the curve, so it's heading towards negative infinity. So the lowest y value can go is negative infinity. And that's it. All right, so in the next video, I'll be going over level 3 and level 4 problems. So check that one out if you need more help. Bye, guys.